Good morning. I say good morning, but you probably say good evening because as a teenager, I'm sure you're watching this late into the night. We're looking at the alternating series test, and before we get going on the alternating series test, let's make sure we know what the heck we're talking about. What's an alternating series? You probably know, but let's put it into math language. We're choosing the most friendly example you can have in the world, which is the harmonic series, the golden retriever of the series world. It's a divergent harmonic series because every harmonic series is divergent. But if I add on this little piece, -1 to the n power, I now have an alternating harmonic series because as you cycle through the n equal 1, 2, 3, 4, 5, this becomes a positive, then a negative, then a positive, then a negative. And you can write these different ways, but in the end, you're always going to have a positive and negative alternating effect. And I said you can write them different ways. You could really trick it up if you wanted to. This does not look like an alternating series, but as you cycle through n equals 1, 2, 3, 4, and so on, you're getting things like cosine of 1 pi, cosine of 2 pi, cosine of 3 pi, which means you're cycling from this to this to this. You just keep going around the unit circle, and the cosine values in those cases are either +1 or -1. So that right there is really that right there in different costume. And sometimes I put this alternator out in front as a coefficient, but it can be a numerator, same thing. Oh, you might not be able to see that. It could be a numerator, same thing. And also notice I started at n plus 3, but it's still going to alternate as I go through my n's. So an alternating series just makes sure that the signs alternate. There's different math language ways to get that done. That's the most popular. Now we need some rules. So how can we determine if an alternating series is convergent? Notice we're not saying anything about divergence, we're just determining if it's convergent, and there's two conditions that have to be met. That's math language for something that you can easily put into English, so we're going to talk about that in a moment. And this is just telling you that the limit of all your terms as you're heading out needs to be approaching 0. And this is basically saying ignore the signs, the positive and the negatives, because the absolute value just says, we'll just treat everything as positive. Is your future term smaller than your previous term for all terms? Or you could say for all n if you want to feel a little bit fancier in the math world. And I put that in English over here. The absolute value of each successive term is smaller than the absolute value of the previous term. So you have to say yes to both of those conditions if you want to say the alternating series is convergent. If you can't say yes to those two conditions, you can't necessarily say divergent. You've just failed to conclude that it's convergent. Lawyers. So this is how it would look if we were going to fight the golden retriever of the alternating series world. This is an alternating harmonic series. Remember that the harmonic series is divergent, but the alternating harmonic series ends up being convergent, and here's why. We can safely say that each future term in absolute value terms is less than the previous term, and sometimes to do this you might need to start cycling through your n equals 1, 2, 3, 4 and start writing it out. Especially when things are more complicated than what you see there. And then the next condition is the limit as n approaches infinity of this thing, or of this thing is a better way to say it, should equal 0. And it does. Now this limit can get a little bit tricky because as soon as you start doing limits with things that are alternating sign, your brain can kind of play tricks on you. So one piece of advice I have for you is take the alternating part and just write it separately than the non-alternating part so your brain can think of two different things. As n approaches infinity, that piece is going to become 0 because the denominator becomes so huge. if that thing is 0, then I don't really care what's happening over here, because 0 times anything ends up equaling 0. That's how I got that. I said yes to both of those, and then I write it succinctly for the AP grader to really admire my work. But now let's unveil a juicier problem. There it is. Okay, so we have much more going on here. You probably recognize this as an alternator because you've just been told it earlier in the video. But remember, a week and a half from now, when you have other things bouncing around in your brain, you may or may not recognize that as an alternator. And it's never a bad idea, depending on how much time you have at your disposal, to cycle through a few ends and start writing out your terms. Okay, so I look at this and I say, okay, that's definitely an alternating series. So I know I need to think about these 2 bullet points that I've memorized. And I can tell by writing out this series that each future term is smaller than the previous term, ignoring the absolute value. So I've said yes to the first bullet point, number 1. Now I need to say yes to number 2 if I want to call this thing convergent. So I've taken the time to rewrite this into this form just because it's going to be easier for us to think about the limit. As n approaches infinity, if I ignore the alternating sign for a moment, this piece right here ends up equaling 1/2. As n approaches infinity, this is not closing in on a value. As I keep going to larger n's, this keeps going to +1, -1, +1, -1. So this part of my fraction, or this part of my series notation, is closing in on 1/2, while the sign keeps alternating back and forth. That's kind of a deep concept, but basically what we're saying is, you see this, if I were to continue on and go way out towards infinity, eventually I'd have essentially a 1/2 that's alternating between positive and negative. Well, if I'm alternating between positive and negative 1/2, I'm really not closing in on a specific value. So my limit there is well, hold on one second. I was going to try to give you a value for the limit, but I don't know the value. The value does not exist because it's just bouncing around between positive 1/2 and negative 1/2. But we can say this because the bullet point just asked, does that limit equal 0? Well, I'm going to say it doesn't equal 0. I don't even care what it is. I just know that it's not 0. So I said yes, but then I said no to the second bullet point. So I cannot declare that it's convergent. So I say no conclusion via the alternating series test, but here's a nice little lesson. The nth term divergence test, which is usually the test you would do first before you consider any other tests, would have declared divergence right off the bat. As I approach infinity, the limit of this monster does not equal 0. Even if I don't know what it is, but I know it's not 0, that's enough for me to say divergence. So the alternating series test was inconclusive. The nth term divergence test confirmed divergence. You're starting to accumulate quite a few rules. Please make sure you're very organized so that you have some way to study and know all the nooks and crannies and lawyer-like subtleties of these rules. See ya.